Welcome to Eclassopedia. I am Rashmi, physics teacher in Eclassopedia. I have done my ME in April Electronics and I have 10 years of teaching experience in an engineering college. I would like to teach physics for ICSE IB curriculum from 8th grade to 12th grade. Today we are going to discuss the topic Ohm's Law, some fundamental concepts of electric current and potential difference, and finally we will discuss some numerical problems based on Ohm's Law. Let's go into the topic. Ohm's law is the basic law of electricity. It gives the relationship between the electrical quantities, voltage, current and resistance. Before going into detail, let's see what is electric current and potential difference. What is electric current? Consider a conductor or a metallic wire. The flow of electric charges through the conductor will produce electric current. What is electric charge? Electric charge is nothing but negatively charged electrons. So, electric current can be defined as the amount of charges or amount of electrons flowing through a particular area of a conductor in unit of time. So, electric current is the rate of flow of electrons or rate of flow of charges in a conductor. So, let Q be the amount of charges flowing through the conductor in time t. Let Q be the amount of charges flowing through the conductor in time t. Then current produced in the conductor is given by I is equal to Q by T. And I is the current in ampere, Q is the charge in coulomb, and T is the time in seconds. Okay, so 1 ampere electric current is produced in a conductor when 1 coulomb of electric charges flowing through the conductor in 1 second. So, electric current is the rate of flow of electric charges or electrons. And current is usually measured by ammeter. And if we consider an electric circuit, a device is connected to the battery through a metallic wire, then naturally electrons will flow through the metallic wire, and from the diagram itself it is clear that the direction of current will be opposed to the direction of electron flow. And let me ask you one thing. What makes the electrons flow from one point to other point? How the electrons flow from one point to other point of a conductor? What makes it flow? Let's see. I will say one example. Consider a water pipe. Okay. For the water to flow from one end of the pipe to other end, there should be some pressure difference, isn't it? Similarly, for the electrons to flow from one point of the conductor to other point, there should be some electrical pressure difference, and that is given by the potential difference. So, potential difference is the amount of work done to move a single charge from one point of the conductor to other point. So, that is potential difference. Potential difference is usually expressed in volt. And potential difference is equal to amount of work done to move a single charge from one point to another. Okay, and it is expressed in volt. 1 volt is equal to, and what is the unit of work? Joule. 1 joule divided by 1. What is the unit of charge? Coulomb. So 1 volt is the potential difference is developed in a conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to another. So that is the potential difference. So now we have learned what is electric current and what is potential difference. And is there any relationship between the voltage and the current in a conductor? Yes, that is given by Ohm's law. So Ohm's law states that is given by Ohm's law, and Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference between its endpoints, keeping the temperature remains constant. So that is Ohm's law. It can be also stated that It can be also stated that voltage or the potential difference developed in a conductor is directly proportional to the current flowing through it. V is proportional to I, and V by I can be, therefore V by I can be written as a constant, and that constant is called resistance of a given material at a given temperature. And resistance of a given material or resistance of a conductor depends upon its length and area of cross section. So R, resistance of a given material, means resistance offers some oppositions, or it resists the flow of electrons in a conductor, and that resistance value depends upon the length of the conductor and also area of cross section of the conductor. R is proportional to L by A, and R can be written as resistance equal to a constant rho into L by A, and rho is called resistivity of the material. Resistivity of a given material. So by Ohm's law, it says that the current flowing through the conductor is proportional to the potential difference between its endpoints. I is proportional to B. It can be also stated that B is proportional to I at a constant temperature. That is, V by I is equal to R, or V is equal to IR. That is Ohm's law. So, for the electrons to move in a conductor against the resistance or against the opposition, it should need some external force, right? So, that external force or external energy is given by the voltage. That is, voltage is called electromotive force. So, when voltage is given to the electrons, so electrons can move in a conductor against the resistance. So that is given by Ohm's law. From this relation, it is clear that V is equal to I into R. From this relation, we can clearly understand that current and resistance are inversely proportional, and voltage and resistance are directly proportional. Which means if resistance is high, voltage to be applied will be very high, and if resistance is less, voltage to be applied will be very less. That is shown in this figure. If resistance is low, resistance decreases, the voltage applied also decreases, and if resistance increases, voltage to be applied also increases. So the greater the electrical resistance value, the greater the voltage to be applied to drive the same current. Okay, so that is the relationship between the voltage, current and the resistance. That is the Ohm's. And if we plot the Ohm's law in a graph, we can get the graph like this. That is voltage along the x-axis and current along the y-axis. And we from the graph, it is clear that there is a linear relationship between the voltage and the current, isn't it? The voltage and the current shows the linear relationship. For a particular value of voltage, there will be a particular value of constant value of current. Okay, so that is Ohm's law. And let's do problems. Okay, so first question: how much voltage gives 5 ampere of current through a 3 ohm light bulb? Can you do that? We know the equation. What is the equation for Ohm's law? V is equal to IR. So from the equation, we can calculate these values. And the second question is, how much current flows in a circuit when 1.5 volt battery and 3 1 ohm resistance in series? You can do this problem if we understand the Ohm's law. And hope you like this video, and if you know the answers, please do write in the comment box. And if you are interested in the subjects, please register the Eclassopedia. Thank you.